Hi and welcome back. My name is Dylan Mendonça and you're with DylAcademy and we're doing paper 4H of math from November 2007 and this is part 3. Okay, so the next question is just a Venn diagram and the numbers in the Venn diagram they say are the number of elements in each set. So first question is find the number of elements in P, in the set P. So if you just look at the set P, it's this circle here. So in set P there's 5 as well as 3. So that just makes the number of elements in set P 5 plus 3, which is equal to 8. Now we'll do number 2. They're asking to find the number in Q apostrophe. Now what is this apostrophe? It actually stands for prime. Q prime is basically everything outside of Q. So Q not included, meaning, so they're asking for the number of elements outside of Q. So if this is Q, everything outside of Q should be this, all of this stuff. So what is outside of Q? It's number 5 and number 7. So it means the number of elements outside of Q is 5 plus 7, which is equal to 12. So 19.3, they're asking for the number of elements where P intersects Q, which intersects Q prime. Now this upside down U is nothing but intersect. And what it means is, what do they have in common? So P intersects Q is this spot, because 3 is what they both have in common. Now, for Q prime includes everything outside of Q. Right? So Q prime does not include this bit over here. So that means that Q prime and P intersect Q have nothing in common. So that means your answer should be 0. Okay, the next question, 19.4, is number of elements in P prime union Q prime. Now this U is nothing but union. And it basically means all of the numbers in like both of these sets. So first of all, let's decide what P prime is. So P prime is everything outside of P, meaning it's all of this. Right? And Q prime is nothing but everything outside of Q, which is all of this. So all that does is it leaves the middle part, where P intersects Q, it leaves that out. So union includes all of the numbers in all of these sets. So all of the shaded area, which I've shaded in this, should be P union Q prime. So if you look at all the numbers, that's nothing but 5, 7, and 4 elements. So you add these together to get your total number of elements. So 5 plus 7 plus 4, and you get an answer of 16. And that's it. Okay, 20a. They've given you a curve with an equation of x cubed minus 5x squared plus 8x minus 7. And they're asking you to find the gradient at 2, negative 3. Now first of all, before we start this question, I'm going to tell you it has to do with differentiation. Now for all of you who don't remember differentiation, look at the note on the side. Basically, if you have y is equal to x to the power of n, the differentiated form of it, dy over dx, that's the notation, is equal to n, basically this n comes down here, and it gets multiplied by x, and then basically that power gets subtracted by 1. So if you had x cubed, this 3 would come down here and be multiplied by x, so 3x, and it would be 3 minus 1. So your full answer would be 3x squared. Okay, then the next note. If you have, for example, 6x and you want to differentiate it, what happens to the x is it's basically x power 1. So this 1 gets multiplied by 6, so it becomes 6, and x to the power of 1 minus 1 is x to the power of 0. And as you all know, anything to the power of 0 is 1. So it becomes 6 times 1, and so it stays at 6. So when you're differentiating, like 6x or 5x or 4x, it just becomes a number. And lastly, when you're differentiating a constant, which I've written down here, where n is a constant, just a normal number, let's say if I'm differentiating this, it just becomes 0. Okay, now knowing all of this, first of all, differentiation basically gives us the gradient. it's basically a way of finding the gradient. dy over dx of any equation will give you the gradient at a specific point. So basically, if we differentiate the first equation, so we get dy over dx is equal to, so the 3 comes down in x cubed, it becomes 3x squared, and then the 2 comes down in 5x squared, and it basically gets multiplied by negative 5, so it becomes negative 10. Then the x squared gets x to the power of 2 minus 1, which is x. And then 8x, as I explained to you earlier, just becomes 8. And 7 becomes nothing but 0, since it's a constant. So this is your dy over dx. Next, they're asking you to find the gradient of the curve at 2, negative 3. All you have to do, since dy over dx is nothing but m, all you have to do is substitute a value for x into this equation, and you'll get your gradient at that point. So all you do is you substitute into this dy over dx, so you just substitute 2 into it, so it becomes 3 times 2 squared minus 10 times 2 plus 8, which gives you a value of gradient as 0. So that means the gradient at that point is 0. The next question is basically saying that what does your answer to part A tell you about the point 2, negative 3? So the answer to part A was that the gradient was 0. So what does that tell you? First of all, I'll show you an example. First of all, if you look at a quadratic graph and you draw, let's say, a tangent over here. Sorry, it's not, a tangent is where it touches at one point. Let's say you draw a tangent. Now in this case, what is the gradient of this line? It's 0, since it's a horizontal line. So, and let's say the same thing occurs for like a maximum point. Let's say you drew a tangent again, sorry it's not touching. What would the gradient be here? It would be 0, since again the tangent is a horizontal line. So, if the gradient is ever 0, that means that the point is nothing but a maximum or a minimum point. Or you can just say it's a turning point. So, what does that tell you? It tells you it's a turning point. Or it could either be a maximum or a minimum point. It's because the gradient is 0 at that point. Okay, in this next question, you're given a histogram and a table showing the annual wine consumption and the frequency. So first of all, what a histogram is it basically plots frequency density against annual wine against another variable. So what is frequency density? Before we start, I'm going to tell you what frequency density is. It's nothing but frequency divided by class width. Now, frequency is the number of times something occurs. So, for example, you hit a ball 5 times, the frequency of you hitting the ball is 5. The class width is nothing but, like, over here, look at the range of values. It's from 40 to 60. So that makes the class width 20. It's the difference between the lower limit and the upper limit, basically. Oh yeah, sorry for this. It's from the screenshot. Just forget about it. Yeah. So frequency density is frequency over class width. Now, how are we going to solve this question? First, we're not given any values for the y-axis, so we have to determine the scale of the y-axis. And to do this, we need to look at this one over here, the class width of 20 to 40. Now, the class width is nothing but 20, and the frequency is 20. So that makes the frequency density 20 over 20, which is equal to 1. So that means that this part in the graph should be 1, this line. Okay, and so now we have a scale for the graph. So now we can continue labeling the graph. So that makes this 2, that would make this 3, and that would make this 4, since it follows the same scale. Now, they're asking us to plot the other bars. So first of all, we need to find a frequency density for the topmost one. Let's do it. So for the topmost, from 0 to 5, the class width is 5, and the frequency is 21. So that means the frequency density should be frequency 21 over class width, which is 5. And that would give us an answer of frequency density of 4.2. So now we got to plot this on the graph. Now how do we do this? Basically, we plot this on the x-axis and frequency density on the y-axis. So let's start with the x-axis. It goes from 0 to 5. Okay, so that's the x value. And it goes up till 4.2, which is here. So then all you do is you just draw it down, and there you've done it. Now we'll do the next one. This next one, we have to find the frequency density. The class width here is 15. So it's nothing but 18 over 15. And so the frequency density is 1.2. So that just, okay, so now we have to plot this on the graph. Basically, we plot the x-axis first. It goes from 5, which is here, to 20, which is here. And then it goes up to 1.2. And 1.2 on the x-axis is from here. So all we do at 1, we just draw straight at 1.2, and that's it. So this is the second one drawn. Now, we still have to fill in the table, which is here. Now, in this part, we know what the frequency density is. We know the frequency density is over here. So it goes, if you extend this line straight from here, you go straight to the edge, you'll find out that the frequency density is nothing but 0.4. Okay, so we know that the frequency density is 0.4. And we also have the class width, which is from 40 to 60. So that means the class width is 20. Now, all we have to do is rearrange this equation to find out the frequency. So if we multiply both sides by class width, frequency will be equal to frequency density, so I'll write it down, F for frequency, will be equal to frequency FD times class width times CW. So all we do is we substitute our frequency density and we substitute our class width. So frequency will be equal to 0.4 times 20, and so frequency will be 8. So that means frequency is 8. Here's just a cleaner version, so you can copy it down in your past paper. Now for question 22, it's basically, there are all these geometric rules about circle and circle properties, and they're a bit difficult to explain in this, it'll take really long to explain. So what I'm going to do is I'm just going to show you the answers. So basically in 22A1, you're being asked to find angle DAC. So DAC. So you need this angle right here. And you are given that angle B is equal to 38 degrees. Now if you look at these two triangles, one triangle is here, and then the other triangle is here. Now both of these triangles lie on the same arc. Okay? So that means that both of these angles should be equal. And it's just a rule. And so that means angle DAC should be 38 degrees. And the reason for this is because they're angles in the same segment. In the same segment. And it's because these two triangles are on the same arc here. So that means that these angles should be equal. Okay, so for 22B, you're being asked to find the angle ACD, meaning this angle in this triangle. Alright, so first you need to know this thing over here. Basically, if AB is the diameter of the circle, and it forms a triangle, C should be a right angle triangle. Now, for the proof, I suggest you look in a book or you look online, but this is the rule. Basically, if AB forms a diameter, and basically it's inside the semicircle, right, and it forms a triangle, this angle should be a right angle triangle. So now applying this rule to this question, in this question they tell us that AC is the diameter. So meaning it forms a semicircle here, and then here's the triangle. So since that's the diameter, that means that angle D should be a right angle, a 90-degree angle. So, knowing this, knowing that angle D is 90 degrees, angle A is 38 degrees, and our knowledge of triangles and their angles adding up to 180 degrees, so that means that 38 plus angle D, which is 90 degrees, plus C should be, angle C should be equal to 180 degrees. So angle C should be 180 degrees minus 38 degrees minus 90 degrees, and so angle C is equal to 52 degrees. And in this question, I suggest that you always show that you know that angle D is a 90 degrees. So you put the mark of 90 degrees in the diagram, or state that angle ACD is 90 degrees because of because it's the angle inside the semicircle or something like that. Okay, in 23 you're being given f of x, two functions, f of x and g of x. They're two different functions, and basically f of x is 3x plus 2 and g of x is 2x minus 5. For 23a, you're being asked to form a composite function, which is basically the combining of two functions into one. And basically you're being asked to find f of g of x. So to do this, I first suggest that you write down g of x. So g of x is nothing but 2x minus 5. Now, this has to be put inside f of x, since it's f of g of x. So it means that you think of this as your x for f of x. So all you do is you substitute this in place of the x in the f of x function. So f of x is 3x plus 2, right? Now all you do is you take this and you put this over there. So it becomes 3 times 2x minus 5 plus 2. And now all you got to do is simplify. So multiply each, you get 6x minus 15 plus 2, which gives you 6x minus 13. And that is f of g of x. Okay, so for 23b, you're being asked to express the function f negative 1 in the form f negative 1 of x. Now f negative 1 to the power of negative 1 is nothing but f inverse. So forget the g for now, we don't need that. So f inverse of x. What happens when you inverse a function? Basically what happens is if the coordinate was originally xy, it now becomes yx. So knowing that, I'm going to teach you how to do the inverse function. So in this case, you can say f of x is nothing but y, because you could write y is equal to 3x plus 2, and that would be your function. So you can rewrite this function, f of x, as y is equal to 3x plus 2. Now, for the inverse function, the x's become the y's. So that means that this x and this y should be swapped around. So x is equal to 3y plus 2. But this is not in the form y is equal to mx plus c, which we normally want it in. So all we got to do is solve for y and make y the subject, and that'll be your inverse function. So to do that, all we do is we subtract 2 on both sides. So we get 3y is equal to x minus 2. Then we divide both sides by 3. So y is equal to x minus 2 over 3. And that's your inverse function. And they want you to write it in this form. So all you got to do is write f inverse of x gives you x minus 2 over 3. That's it. Okay, 24, you're basically given two boxes, box A and B, and you're being said that there are 3 black counters and 2 white. You can read the question, okay? You read the question and you know that there are a certain amount of black and white boxes. And first of all, counters in each box. So first of all, Farah takes a random counter from box A, then puts it in box B. Okay? Now, it could either be a black or a white counter. I want you to understand that first of all. And then she takes a counter from box B. So you have to work out the probability that the counter she takes from box B will be black. Okay, so first of all, you have to consider the two possibilities of happening. The two possibilities that could occur. First of all, she either takes a black counter from box A. Now, what's the probability that she'll take a black counter from box A? It's 3 out of the total number, which is 5. So 3 out of 5. And then she puts it in box B. So now in box B they have 3 black and 1 white. So that means this gets so then the probability of her picking a black bead would be 3 out of 4. Right? Okay, now the second instance that could occur is where she takes a white counter from box A and she puts it in box B, and all of a sudden, so what's the probability of her choosing a white counter? It's 2 out of 5, and she puts it in box B, and then all of a sudden she has one more white counter, and so the probability of her picking a black counter would be 2 out of 4. So these are your two instances. All you need to do is figure out the total probability, and all you need to do that is just add these two instances together. So you get an answer of 13 over 20. So first you just multiply these, and then you add them together. I might not have explained that perfectly, but if you have any questions, please post in the comment section if you don't understand, and I'll help you for sure. Okay, so thanks a lot for watching part 3. Please comment if you have any questions. Again, maybe a few things I haven't explained perfectly. Please rate and please subscribe this video to my channel. And please go on to watch part 4. Thanks a lot, guys. And yeah, sorry if it's taking a bit long. It's just that these 4H papers are